What if your phone never died? What if a pacemaker could run for centuries without ever needing a battery swap? What if your car, spacecraft, or even a satellite could operate for thousands of years without ever plugging into a power source again? No recharging, no refueling, just pure, uninterrupted energy for generations. Sounds impossible, right? Well, brace yourself, because scientists have developed something that might just upend everything we know about power and longevity. It's called a nuclear diamond battery. And it's not science fiction, it's science fact. And this little energy miracle might just change the world as we know it. Subscribe, hit the notification bell, and smash that like button, because this is Tech Mythos, where we break the silence around future tech, one myth at a time. And what you're about to learn might just change how you think about energy forever. Let's dive into the future. The story begins with something most people are terrified of: radioactive nuclear waste. Nuclear reactors generate massive amounts of radioactive material, much of which has to be stored and monitored for thousands of years. One of those byproducts is carbon-14, a radioactive isotope found in graphite blocks used in reactor cores. Carbon-14 emits beta particles, essentially high-speed electrons. Normally we think of this decay as dangerous. But what if we could trap that decay inside one of the hardest substances on Earth and convert it into power? Enter artificial diamonds. Scientists found that by extracting carbon-14 from graphite blocks and encapsulating it within lab-grown diamonds, they could create a power source unlike anything else on the planet. The diamond doesn't just serve as a radiation shield, it's also a semiconductor. So as the carbon-14 decays, the diamond structure captures the emitted electrons and converts them into electricity. Clean, consistent, and long-lasting energy. Not a blast, not a surge, but a slow, steady trickle of power that doesn't stop for tens of thousands of years. We're talking about energy that outlasts civilizations, literally. At the forefront of this breakthrough is a company called NDB, short for Nano Diamond Battery. Based in California, NDB has announced its nuclear diamond battery prototypes can last over 28,000 years. That's right, 28,000 years. To put that into perspective, that's longer than recorded human history. It's longer than the Great Pyramids have existed. It's longer than many species remain on this planet. These batteries could still be running in the year 30,025. So how does it work? The heart of the battery contains the radioactive carbon-14 encased within a diamond. Around that, a non-radioactive diamond layer acts as a protective shell, blocking any radiation from escaping. The energy is harvested through the decay process and transmitted through the diamond's lattice structure as a usable current. And because there are no moving parts, no chemical reactions that wear out, there's nothing to degrade. The result? A solid-state battery that produces a small but steady stream of energy for millennia. Not hours, not days, not years, millennia. Now let's talk use cases, because this isn't just a theoretical toy for lab geeks. These batteries have real-world implications that are staggering. First off, medical implants. Think of pacemakers. One of the biggest challenges for heart patients is replacing the battery every few years, a procedure that carries real surgical risk. But with an NDB, a single implant could last a lifetime. No surgeries, no replacements, ever. Then there's aerospace. In deep space, solar energy only works when you're close to the sun. Beyond the asteroid belt, sunlight becomes too weak to be reliable. That's why spacecraft use bulky and risky RTGs, radioisotope thermoelectric generators. But nuclear diamond batteries, they're smaller, safer, and could power deep space missions for centuries without ever needing a recharge. A single Voyager-type probe could send data back from interstellar space well into the next era of civilization. And back here on Earth, think about IoT, the Internet of Things, billions of tiny devices embedded into homes, cities, farms, oceans, and forests. Most of these run on lithium coin cells, which need replacement every couple of years. Imagine a sensor you install once, and it keeps sending data for hundreds, maybe thousands of years. No maintenance, no battery swap, just enduring intelligence. Now let's talk safety, because anytime you say the word nuclear, people's minds immediately go to disasters. But this technology is fundamentally different. Carbon-14 is a weak beta emitter. It cannot penetrate human skin. In fact, a piece of paper is enough to stop it. And in the NDB design, that carbon is locked inside synthetic diamond, one of the hardest and most impermeable materials known to science. The outer shell is non-radioactive diamond that absorbs any stray emissions. You could literally hold this battery in your hand with no ill effects. By comparison, you're exposed to more radiation from a granite countertop or a cross-country flight than from an NDB. It's that safe. And unlike lithium-ion batteries which can overheat, swell, or even explode, NDBs don't generate heat spikes. There's no chemical reaction, no fluid, no degradation, just consistent stable output. Let's put this in everyday terms. Lithium-ion batteries typically last 500 to 1,500 charge cycles, roughly 2 to 3 years of regular use. Their performance drops off, they swell, they require constant charging, and the environmental cost of mining lithium, cobalt, and nickel is staggering. It's one of the most toxic and exploitative industries on the planet. Now contrast that with a battery that runs off recycled nuclear waste. It's solid state. It doesn't degrade, it doesn't pollute, and it doesn't need a single recharge for tens of thousands of years, and that's not even the most exciting part. Imagine a future where electric vehicles are powered by nuclear diamond batteries, no charging stations, no grid dependency, just self-contained, long-duration energy sources that outlast the vehicle itself. Think of fleets of autonomous delivery vehicles that never need to plug in. Think of drones mapping forests, oceans, and disaster zones with unlimited range. What about remote infrastructure? Cellular towers in the middle of nowhere, Arctic research stations, ocean buoys, undersea communication relays. These systems are incredibly expensive to maintain because getting power to them is a nightmare. But if they were powered by NDBs, you'd install it once and walk away for good. It would just work, silently, forever. Military and defense applications, absolutely. You could power surveillance equipment, satellites, communication nodes, and autonomous systems in areas where grid power doesn't exist or where stealth and longevity are essential. If this is blowing your mind, and we're just getting started, hit that like button, share this video, and drop a comment below. What would you power with a battery that lasts 28,000 years? Now let's talk logistics. This all sounds amazing, but there are challenges. First is public perception. People fear nuclear energy, sometimes with good reason. But this is not uranium. This is not plutonium. This is not fission. It's low-energy beta radiation, sealed in diamond, completely inert from a safety standpoint. Still, overcoming that stigma will take time. Companies like NDB will need massive public education campaigns. They'll need to demystify the tech, compare it with everyday radiation exposure, reassure users, and earn trust. Then there's regulation. Anything nuclear, even ultra-safe tech, requires a gauntlet of approvals. Different countries have different standards, and right now, regulatory frameworks don't even exist for this kind of battery. That means policy must catch up to innovation, a challenge in any field, but especially in nuclear science. Another challenge, scaling the extraction of carbon-14. It's not something you can do with a backyard chemistry set. It requires sophisticated reactors, shielding, and containment systems. That adds cost, which brings us to pricing. Early on, NDBs will be expensive. Very expensive. Like most new tech, they'll serve high-value markets first. Space, defense, medical. But over time, as production scales and demand grows, costs will fall. Remember, early computers cost millions. Now they fit in your pocket. Eventually, these batteries could become standard in consumer electronics. Phones, watches, laptops, wearables. Always-on devices that never need a wall plug again. And if you think that's wild, consider hybrid systems. Imagine pairing a small NDB with a lithium-ion battery. The NDB constantly trickle charges the lithium battery, eliminating the need for external charging altogether. You'd still get the energy surge from lithium when needed, but without ever plugging in. Self-sustaining, renewable, and eternal. That's not just an upgrade, it's a paradigm shift. Let's go further. Imagine entire homes powered by arrays of NDBs. No wires, no monthly bills, no outages, or portable power units you take into the wild, backpacking, camping, off-grid exploration, never worrying about fuel or sunshine, pure autonomy, and we haven't even touched on disaster response. In the aftermath of hurricanes, wildfires, or earthquakes, the power grid collapses. But communication is critical. Imagine emergency transmitters powered by NDBs. Drop them in, forget them. They'll broadcast emergency signals for centuries, a permanent safety net. Even agriculture could change. Sensors that monitor soil moisture, temperature, and pest activity, running for decades, supporting precision farming and boosting yields sustainably. And maybe, just maybe, this is the tech that finally ends our toxic relationship with disposable batteries. The hundreds of millions of AA, AAA, and coin cell batteries that end up in landfills every year, gone. Replaced by something infinitely more powerful and infinitely more sustainable. We're standing at the edge of an energy revolution, one that doesn't just upgrade what came before, but reinvents it from the ground up. Nuclear diamond batteries are not science fiction, they're science future, and they're already here. So, next time your phone runs out of juice or you're waiting for your smartwatch to charge, remember, somewhere in a lab there's a tiny diamond quietly pulsing with power, and it will keep going for 28,000 years. This is Tech Mythos. If this video expanded your mind, be sure to like, subscribe, and turn on notifications so you never miss what's next. Drop your thoughts in the comments. We love hearing from forward thinkers like you. Until next time, stay curious, stay innovative, and stay mythic.